Okay, let's unpack this. The ultimate cosmic question, are we alone?
It's the big one, isn't it?
For centuries, it's been the stuff of dreams and, well, the focus of some seriously smart people.
Absolutely.
Today, we're taking a deep dive into the modern search for extraterrestrial intelligence, SETI. We've got a fascinating conversation with Dr. Shelley Wright as our launch pad here.
And what's really interesting right off the bat is seeing how the whole search has changed.
Oh,
It's not
really?
just listening for cosmic radio anymore.
No, exactly. It's gone visual.
Mm-hmm.
So in this deep dive, we're zooming in on some really cutting-edge methods, ways to spot potential ET civilizations, especially looking at what they call optical technosignatures.
Like alien laser pointers, basically.
Sort of. Think alien laser beams, yeah. And we'll also get into what finding even, say, fossilized life nearby could mean for that big question.
Right. Even finding past life on Mars or Europa would be huge.
Totally. We've gathered some really compelling stuff for you, including insights from Dr. Wright herself.
Mhm.
Our mission today, to really try and grasp these new frontiers in SETI and, what it all might mean for us, for our place in the universe.
Sounds good. Where should we start?
So let's get right to it. These optical technosignatures. What exactly are we hunting for?
Okay, so imagine a kind of cosmic flashlight. That's the basic idea. We're looking for artificial light sources.
Okay.
And Dr. Wright's work is really pushing the boat out on using lasers. The thing about a laser is its sheer intensity.
Right, they're bright.
Incredibly bright. Even what might be a modest laser for an advanced civilization could, theoretically, be bright enough for us to spot across, well, vast interstellar distances, with surprisingly sensitive gear here on Earth.
Huh. So instead of just listening, hoping to overhear a faint radio whisper, we're now actively scanning the skies for these super bright, maybe really short flashes of light.
Exactly. It's like switching from listening for drums to looking for a strobe light, maybe.
That's a good way to put it.
And one of the key projects doing this, Panoramic SETI or PanaSETI Dr. Wright is deeply involved, is designed specifically for that.
Right.
It uses this array of small, quick lenses, basically constantly watching the sky, looking for those fast, powerful bursts of light, mostly in the visible and near-infrared parts of the spectrum.
Okay, so what kind of light show are we actually expecting? I mean, how do you tell the difference between, say, an alien super beam and just a star exploding or something?
Yeah, that's the million-dollar question, isn't it?
How do you know it's unnatural?
That's precisely the challenge, identifying what's truly unnatural. The PanaSETI team is basically hunting for anomalies.
Hmm.
For flashes of light that just don't fit the pattern of any known natural thing, supernovae, variable stars, that sort of stuff.
Okay.
They're trying to pick out a deliberate technological signature from all the universe's regular fireworks. So it's about looking for patterns or maybe characteristics that just scream artificial.
It's interesting, though, how radio waves were the main focus for so long. Why the big shift towards optical now? Are lasers suddenly the cool way for aliens to communicate?
Well, radio waves definitely have a big, plus they slice right through the interstellar medium, gas, dust.
Hmm.
It doesn't stop them much.
Right, I remember that.
That's why they were the first bet.
Hmm.
But lasers, they offer that incredible focused intensity we talked about.
Mm-hmm.
A laser beam aimed, say, right at our solar system, could be unbelievably luminous, really detectable, even if it's only on for a little while.
Ah, so it's good for targeting specific spots.
Exactly. Ideal for zeroing in on potentially interesting star systems. And, as Dr. Wright's work shows, we're also getting much better infrared detectors now, which broadens the types of artificial light we might be able to catch.
That makes total sense. Focus the beam, make it really stand out.
Yeah.
But, okay, with all the scanning, I just imagine the noise. Earth must be incredibly messy, technologically speaking.
Oh, you've absolutely hit on a critical point there. The interference is a massive, massive hurdle. Just think about it. Satellites zipping across the view, airplanes, even weird reflections or twinkles in our own atmosphere. They can all create signals that look artificial at first glance.
Right, false alarms.
Exactly.
Yeah.
So a huge part of the work in both optical and radio SETI is building these incredibly clever algorithms and techniques to filter all that Earth-generated stuff out.
It sounds like a constant battle.
It really is.
Oh, yeah.
A constant arms race against the false positives.
So let's say, hypothetically, they filter everything out, and they do pick up something genuinely weird. A flash that doesn't match anything natural isn't one of our satellites playing tricks. What happens then? Do they, call the president?
Not quite that dramatic, usually. Dr. Wright and her colleagues, they have a very strict verification checklist.
Okay. Makes sense.
First step, always
Yeah.
check the instruments. Was it just a glitch in the camera, a weird pixel?
Right. Rule out equipment failure.
Then, they meticulously check it against flight logs, satellite databases. Was there anything human-made in that patch of sky at that exact moment?
Got it. Due diligence.
Absolutely.
Yeah.
And only after exhausting all those possibilities, if they still can't pin it on a natural or human-made source, then it might get flagged as a genuine candidate technosignature.
Yeah.
And if it's something really solid, truly anomalous and unexplainable, the standard practice in astronomy is to put out a notice on something called the astronomer's telegram.
Ah, okay. Like a bulletin board for astronomers?
Pretty much, yeah. It's a way to quickly share breaking news so other telescopes can try and look too.
Okay, so a healthy dose of scientific skepticism and careful checks. Good. Now let's pivot a bit. Something that always sparks debate. Actively sending messages.
METI.
Messaging extraterrestrial intelligence. Yeah, this is where it gets ethically tricky.
Tricky is probably an understatement.
The article we looked at brings up Stephen Hawking's famous warning comparing broadcasting our existence to ringing a galactic dinner bell.
Yeah, I remember that. It's a chilling thought. The core worry is just the unknown. We have zero idea what other civilizations might be like, their intentions. Would contact be good, bad, neutral, potentially disastrous?
We just don't know. And it sounds like Dr. Wright shares that caution. She's not exactly advocating we start beaming messages out tomorrow.
No, definitely not rushing into it. Her view seems very measured, suggesting that maybe humanity, isn't quite mature enough yet, technologically or ethically, to be shouting into the cosmos.
Mm-hmm.
And she raises that really fundamental question. Who even gets to decide to speak for Earth, for all of humanity?
That's a huge point. It's not like we have a global committee for alien introductions.
Exactly. It's not a decision one person or one country or even one company should make lightly or, unilaterally.
Which is worrying because haven't some private groups already sent stuff out
Yeah,
without asking anyone?
that's right. There have been efforts, private messages sent towards other stars. The cat's kind of out of the bag in that sense.
So there's no real global agreement or rules?
Not really, no. Which just adds another layer of, complexity to the whole ethical debate.
Okay. Let's shift gears again, maybe bring it a bit closer to home. What about looking for life or past life right here in our solar system, like in those Martian meteorites?
Ah, yes, the Martian meteorite hunt. Dr. Wright touches on this too. Scientists have spent years carefully examining rocks we know got blasted off Mars and landed here on Earth.
Looking for tiny fossils, right? Or chemical signs.
Exactly. Any telltale signs of past biological activity. And while there was that big excitement years ago with one particular meteorite, ALH 84001.
I remember that with the worm-like structure.
That's the one. But the current scientific thinking, the consensus, is that we haven't yet found definitive, absolutely undeniable proof of Martian life in those rocks.
Okay, so no smoking gun yet.
Not in the meteorites, no. But, absence of evidence isn't evidence of absence.
Right, just because we haven't found it yet?
Precisely. Doesn't mean life never existed on Mars. And the search is definitely expanding now. We're not just waiting for rocks to fall on us.
We're going there.
We're going there, and we're looking beyond Mars, too. Think about the subsurface oceans on moons like Europa, Jupiter's moon, or Enceladus around Saturn.
Those icy moons with water underneath.
Yeah. Missions like the Europa Clipper, which is coming up, are specifically designed to go and probe those environments to see if they could actually support life now.
Wow, it's just kind of staggering to think about finding life, even if it's just fossilized microbes on Mars or Europa. What would that do to our whole understanding of biology?
Oh, the implications would be absolutely revolutionary, profound.
How so?
Well, as Dr. Wright points out, think about it. If we found evidence that life started independently, even once elsewhere just in our own solar system.
Just next door, cosmically speaking.
Exactly. It would strongly suggest that the origin of life isn't some incredibly rare, maybe unique to Earth fluke.
It would mean the spark of life happens more easily.
It would imply the conditions, the ingredients, the process for life to emerge might actually be relatively common out there in the universe.
So that would really challenge the whole rare Earth idea, wouldn't it?
Definitely. The rare Earth hypothesis, the idea that Earth's specific combination of conditions needed for complex life, is exceptionally unusual.
Yeah.
Finding life nearby, even simple life, would weaken that hypothesis significantly. It would lend support to the idea that the universe might be, teeming with life. even if much of it is just microbes.
A biologically richer universe than we perhaps imagine.
Potentially, yes. A much
Hmm.
more diverse cosmos.
It feels like Dr. Wright's work, this optical SETI, it connects so directly into this bigger field, astrobiology, and trying to answer that fundamental question about our place. She also mentions the Drake equation, right?
She does, yeah. The Drake equation is, for anyone who hasn't come across it, is basically a framework, a way to try and estimate the number of active communicating alien civilizations in our galaxy.
Kind of a probability argument?
Sort of. It multiplies together a bunch of factors, like how many stars have planets, how many of those planets could support life, how likely is life to arise, how likely is intelligence, how long do civilizations last.
Lots of unknowns in there.
Oh, huge uncertainties in many of those factors, like how long does a communicating civilization typically survive? We have no idea.
We only have one data point.
Exactly. But what Dr. Wright emphasizes, and what's so exciting now, is how the flood of discoveries about exoplanets,
Planets around other stars.
yeah, driven by amazing tools like the James Webb Space Telescope, is starting to give us real numbers for some of those early factors in the equation.
Like how common Earth-like planets are.
Precisely. We're getting much better handles on things like that.
Yeah.
We are genuinely living in a new golden age for finding planets and studying their potential for life. It's incredible.
It really is mind-blowing how much the picture has changed, even just in the last, say, 20 years.
Absolutely.
And it feels so important that scientists like Dr. Wright are out there sharing this stuff with the public, like her work with PBS Novia.
Yeah, that public science communication is vital. It helps people understand why this kind of long-term fundamental research matters, why we should be looking.
Builds support, sparks curiosity.
And her call for more researchers, especially young researchers, to jump into these fields, SETI, astrobiology, they're so interdisciplinary now, it really highlights how significant this quest is for, well, for humanity.
So, okay, let's try and bring it all together, this deep dive. It's shown a really fascinating shift in how we're searching.
From listening to looking.
Yeah, we're not just listening anymore. We're actively scanning for bright artificial flashes, like those potential laser signals. We've also touched on those really deep ethical questions about METI. Should we be shouting, hello?
Big questions with no easy answers.
Definitely not. And we've thought about the huge impact of maybe finding even microbial traces past life right here in our solar system.
How that could rewrite our understanding of life's prevalence.
Right. Ultimately, this whole search, it's not just about finding aliens, is it?
No, I don't think so. It's deeply human. It's about understanding where we came from, where we might be going, and just our place.
Yeah.
Our context in this unbelievably vast universe that just keeps revealing more surprises.
It really does. So thinking about these possibilities that feel, well, maybe less like science fiction now, the potential for detecting a signal or finding that fossil on Mars, what do you, listening right now, think would be the single biggest impact on humanity?
It's a heck of a question to ponder, isn't it?
It really is. Something to keep thinking about as we all continue to watch the skies and explore these incredible cosmic mysteries.
Indeed. We hope you keep exploring this stuff. It really does raise the most profound questions about life, the universe, and, well, everything.